All right, everybody, welcome to our first unit for Pre-Calculus 11. This whole unit, in fact, the first few units are going to be all about something called parabolas and quadratic functions. So you may have seen a little bit of this already, but we're going to dig into them in pretty deep detail. So the first thing we're going to look at is what exactly is a quadratic function. And so a quadratic function, the basic quadratic function has something with the form f of x is equal to x squared. And basically it's a polynomial function that has a degree of 2, which is to say that the highest value exponent in the expression is a 2. And so we're going to just look at how we can transform different changes we can make to these parabolas and how that results. The first thing I want you to think about is what is the basic form of a parabola. So if we look, I've got a table of values here, and so if we think of f of x as just being x squared, remember that's our simplest parabola, if you will. What happens, what is f of x in each of these cases? So I'll start here in the middle of the table. If if x is 0, then f of x is just 0 squared. 0 squared is 0. Let's go down this way and work our way into the positive numbers first. If x is 1, 1 squared is 1, but 2 squared is 4, and then 3 squared is 9. Now let's work our way into the negative values. Negative 1 squared, well, the negatives cancel out, and so that's actually 1. Negative 2 squared, again, cancels out, so that's 4. And then negative 3 squared is, well, that's going to be positive 9. And so I've got a table of values here. I'm going to go ahead and plot that on my grid paper and just see what results. So the first thing I'm going to do is I'm going to plot 0, 0 first, and that's going to be right here in that spot. And then we can see that, well, I'm going to go in the positive direction first just because that works better for me. If I go over 1 in the x direction, then I have to go up 1 in the y direction. So over 1 and up 1, my first point is 1, 1. And then when I go over 2, I actually have to go up 4. So 1, 2, 3, 4. And then when I go over 3 in the x direction, I have to go up 9. So when I go over 3, I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is the first part of my parabola. I'm now going to go into the negative direction. So when I go to negative 1, so when I move left, negative 1, I go up 1. When I go left 2, I go up 4. And when I go left 3, I go up 9. And we can start to see a shape taking form. And so what we actually have, I get you to go ahead and try and draw that. It takes a bit of practice, but we can see that it's definitely curving upwards, kind of that way. And I'm going to add arrows because it goes onwards. And then curves up this way. And there's a few things that we should notice about this parabola, this shape. So it is a curve as opposed to a line. You probably learned a lot about lines last year. The first and most obvious point on a parabola is this point right here, which we call the vertex. And so we're actually going to be talking about parabolas in something called vertex form first. And so the vertex is this point of inflection where it goes from kind of coming down this way and then curving back up the other way. You could think of it as being, for now, as being the minimum point on this parabola. But the other thing to notice about it is that this parabola carries on in both directions. It carries on forever. It's going to keep on going upwards on both the left and the right arms. It also has a symmetry to it. So the left and right side should be exactly the same. So another way to look at it is if we look at, just look at a graphing calculator here. If you punch in y equals x squared, we see we get this shape. No matter how far we zoom out, we're always going to have this parabolic shape going on forever. Okay, so that's our basic form of a parabola. And what we're going to look at is what happens to this function as we start to manipulate it in different ways. So we're first looking at different versions of y equal to ax squared, where a is any constant. So in this first example, it was like a was 1, but what if it was 2? What if it was 1/2? What if it was negative 2? What would result? What would our picture look like here? So but just before we do that, actually, I'm going to do one more. I want to point out one more thing. The basic form for a parabola, I want you to remember that pattern that we followed. I went over 1 step and then up 1 step. Over 2 steps, up 4 steps. Over 3 steps, up 9 steps. And if you think of that as your basic pattern for the simplest parabola, and note that it happens in both directions. So what happens as we go to the right, happens as we go to the left. Okay, let's go ahead and fill in these data tables and then see what's going to happen to the function. So in the first case here, imagine that we do f of x equals 2x squared. So what happens if there's a 2 out front of my x squared value? Well, for x equal to 0, 0 squared is 0 times 2 is still 0. For x equal to 1, 1 squared is 1 times 2 is 2. For 2, 2 squared is 4 times 2 is 8. And for 3, 3 squared is 9 times 2 is 18. And we'll notice the same thing happening. Remember that symmetry that our parabola had? Negative 1 squared is 1 times 2 is 2. Negative 2 squared is 4 times 2 is 8. And negative 3 squared is 9 times 2 is 18. So I'm going to plot this. On my grid and just see what's different. Again, we'll note the vertex starts right here at the same point. But now I'm going to go over one space in the x direction and up 2 spaces. I'm going to go over 2 spaces in the x direction and up 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go over 3 spaces and I'm going to go up 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I almost ran out of space. Oh, 18. I think I did just run out of space somehow. So it's going to be up here somewhere. And the same thing is going to happen on the opposite arm. It's still going to be symmetrical. Over 1 up 2. Over 2 up 8. And then over 3 up 18. And now if I kind of connect my curve, I can see that I'm going to have this kind of shape. And it takes a bit of practice, and apparently I could still use some practice, but we get the rough idea of what that looks like. All right, let's keep going here. Let's do this next one. Y equals 1/2 x squared. Well, we're going to notice a similar pattern. 0 squared still 0. Doesn't matter if we multiply it by 1/2. 1 squared is 1 times 1/2 is, well, that's 1/2. 2 squared is 4 times 1/2 is only 2. 3 squared is 9 times 1/2 is 9/2, I guess, or 4 1/2. And I'm going to see the same thing happening in the negative direction. So the symmetry happens again. I get 1/2 here, I get 2, and then I get 4 1/2. And I'm going to place this over here on my graph. So again, vertex starts at 0, but when I go over 1, I only go up 1/2. When I go over 2, I only go up 2. When I go over 3, I only will go up 1, 2, 3, 4 1/2. And then same thing going this way. Over 1, up 1/2. Over 2, up 2. Over 3, up 4 1/2. And we can see that I've got kind of this wider parabola. Still curving upwards, still going off to infinity, but it's gotten wider on me. So already we can see that by varying this a value, just by varying that a value, we're going to get different forms of that parabola. And what a seems to be affecting is that the width, the steepness of the parabola. The last one we're going to do here is, let's do f of x is equal to negative 2x squared. So similar to this, this one we did in green, but what happens if we have a negative sign there? So negative 2x squared. So 0 squared is 0 times negative 2, doesn't matter, still 0. 1 squared is 1 times negative 2 is negative 2. 2 squared is 4 times negative 2 is negative 8. 3 squared is 9 times negative 2 is negative 18. And we'll see the same symmetry going in the negative direction. Negative 1 squared is 1 times negative 2. Negative 2 squared is 4 times negative 2 is negative 8. Negative 3 squared is 9 times negative 2 is negative 18. And so we can see that our data tables here between the green and the gray are really, really similar, except all of our values are negative. So I start with the vertex at 0, 0, and then I'm going to go over 1. In this case, I'm going to go down 2. I'm going to go over 2, and I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go over 3, space here, and I'm going to go down 18. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and again, how did I leave myself one box short? I should know better. I made these notes. Okay, so same thing on the other side. We're going to have this symmetry, and like so, and I'm going to fill in my curve. Looks like this, and there we go. So we can see that the value of A has sort of two main jobs. It can affect the steepness of the curve, but it can also affect the which way it faces. So whether it faces upwards or it faces downwards. Okay, so we can summarize that here in the bottom. Maybe we'll do a quick, maybe I'll show a quick example here too. So if we take a look here, here's my graph, my regular parabola in black. If I change my value of A, I'm just going to move this A slider. As A gets bigger and bigger, we can see we make a steeper and steeper parabola. And that's going to get steeper and steeper, but never quite perfectly vertical. And then as I go in the opposite direction, if A is smaller than 1, so if it's exactly 1, I get my regular parabola. But if it's smaller than 1, then I get a wider than normal parabola. So anything in this range gives me wider than normal. But if it's not just smaller than 1, but it's actually smaller than 0, we're actually going to the negative range, then the same rules apply, except the whole thing flips upside down. And now I've got an inverted parabola. Okay? So our A value is going to affect both the steepness, but also the which way the parabola faces, whether it faces upwards or downwards. So if A is greater than 1, then it becomes more narrow. If it's between 0 and 1, then it becomes wider. And if it's less than 1, then it becomes inverted. Okay, so we're going to look at two other ways that we can mess around with these parabolas. The next thing we're going to look at is we've got our regular f of x equal to x squared. So there's again our regular parabolic, or our simplest quadratic function. And then what happens if we add something to the end of it? We're going to call that variable q. So what happens if we add something on the end after the x squared? So for example, what happens if we have x squared plus 4 or x squared minus 3? I'm just going to fill in these data tables, and then we're going to sketch the graphs over here and come to some conclusions. Now the first one's really straightforward. We did that last time, and it's going to be the same. So 0 squared is 0, 1 squared is 1, 2 squared is 4. And then same thing here, 1 and 4. So that looks the same. I can draw this, and hopefully eventually you'll get to doing this fairly quickly, where you can just kind of place your vertex point, your 0, 0 point, and then go over 1, up 1, over 2, up 4. And we go over 1 to the left, up 1, over 2, up 4. And you could do more points, but 5's probably plenty, where you can now kind of sketch out roughly what it looks like. And so that's my basic parabola. What happens, sorry, that was f of x equal to x squared. What happens if I have f of x equal to x squared plus 4? Well, x squared plus 4. Well, 0 squared is 0, plus 4 is 4. 1 squared is 1, plus 4 is 5. 2 squared is 4, plus 4 is 8. And we're going to get this symmetry again, where negative 1 squared is 1, plus 4 is 5. Negative 2 squared is 4, plus 4 is 8. And so if I sketch this out here, I can see my vertex actually is going to happen at 0 and positive 4. 1, 2, 3, 4. But then I'm going to go over 1 in the x direction and up 1. Over 2 and up 1, 2, 3, 4. Same thing when I go to the left. Over 1, up 1. Over 2, up 4. And really what we've got here is we've got the exact same parabola, but we can see the only difference now is it's been shifted upwards. Let's try this next one. Let's try f of x equal to x squared minus 3. 0 squared is 0, minus 3 is minus 3. 1 squared is 1, minus 3 is minus 2. 2 squared is 4, minus 3 is 1. And we see that symmetry on the other side. So negative 1 squared is 1, minus 3 is minus 2. Negative 2 squared is 4, minus 3 is 1. So my vertex now is going to happen at 0, negative 3 down here. 1, 2, 3, negative 3. I'm going to go over 1 and up 1. I'm going to go over 2 and up 4. Over 1 this way and up 1. Over 2 and up 4. And you can see the same parabola taking shape, but it's just been shifted downwards. So what does this q value do? What happens when we add something to the end of to the end of the parabola. Well, you can see here I've got the q slider, so there's my basic function. When q is positive, it just takes the parabola and shifts it upwards, just moves it in the positive y direction. When q is negative, just shifts it downwards. Same shape, same pattern, hasn't done anything to change the steepness or which way it opens, just literally shifts it up or downwards. So any q number is just going to shift up or down. Okay? How does the graph change when q is greater than 0? Oops. It shifts upwards. And when q is less than 0, it shifts down. All right. So the last thing we're going to look at is what happens if we take a number and we move it kind of inside with the x squared. We kind of buddy it up with the x squared. So we're going to take a value here and we're going to call it p. What happens if we have p inside the brackets here? And so instead of x squared, maybe we've got like x minus 2 squared or x plus 1 squared. Now I want to point out, when we have, it takes a bit of getting used to, but when we look at vertex form, we always talk about x minus p. So in this case, x minus 2, we would say p is 2. But we always talk about x minus 2, or x minus p. In this case, when we have x plus 1, we always talk about subtracting p. So in this case, p is technically negative 1, because minus negative 1 is positive 1. And that's going to seem weird, and hopefully by showing you this, you'll see why we do it that way, why we bother with the negative sign. So by now, this is old news. X squared, f of x equal to x squared. We know this is going to be 0, 1, 4, and this way 1 and 4. Whoops. And over here, we've got our vertex, over 1, up 1, over 2, up 4, over 1, up 1, over 2, up 4. And we can draw our curve. Very nice. But what happens, like I said, if we change up our p-value? So now what happens if we have f of x equal to x minus 2 and then this whole thing is squared? Well, in this case, put in 0. 0 minus 2 is negative 2. Negative 2 squared is 4. 1 minus 2 is negative 1. Negative 1 squared is 1. 2 minus 2 is 0. 0 squared is 0. Negative 1 minus 2 is negative 3. Squared is 9. Negative 2 minus 2 is 4. Squared is 16. And so it's not immediately obvious what's going on here. That looks like a weird data table, but I'm just going to start at the bottom, actually, and I'm going to start populating from the bottom. So my first value is 2, 0. So that means I go over 2 spaces, and then I'm here at 0. And then if I go over 1 space, I go over 1 space and up 1. And when x is 0, then I'm at positive 4 already. And when I'm at negative 1, I'm all the way over here at positive 9. And when I'm at negative 2, I'm way up here at 16. I can't even fit it in there. So what we can see is, well, I see this shape emerging. And just by looking at that and knowing this is a parabola, we could test some more points, but hopefully what you recognize is actually we've just drawn the left arm of the parabola. That means the right arm of the parabola is right over here and goes like that. And so what we've effectively done by adding in that p-value is this has just shifted it to the right. Let's see what happens with the next function. So x plus 1 squared. So we've got x plus 1 squared. Again, we'll just fill in our data table. 0 plus 1 is 1, squared is 1. 1 plus 1 is 2, squared is 4. 2 plus 1 is 3, squared is 9. Now negative 1 plus 1 is 0, squared is 0. And negative 2 plus 1 is negative 1, squared is 1. So let's start filling in our values here. I'm going to start here at negative 1, 0. So if I go over to negative 1, my value is 0. And then when I go to x equal to 0, I'm up here at positive 1. And when I'm over at x equal to 1, I'm all the way up to 4. And when I'm at positive 2, I go all the way up to 9. And if I go to the left, see if I go to negative 2 here, I'm up at positive 1. Now again, knowing that this is going to be a parabola, we can just sort of fill in the gap. So I've got this arm going this way, and I've got this arm going that way there. And so we can see that that p-value shifted things to the left. And so what happens overall when we've got a p-value? So I can see here, here's my function x minus p. When p is positive, it's going to shift it over to the right. Now remember here, I'm talking about x minus p. So when I subtract a positive value, then I shift it over to the right. If I subtract a negative value or add a number, then it shifts it over here to the left. So the p-value, notice how the parabola doesn't change anyway. It's exactly the same curvature, everything. It's literally just shifting it to the left or to the right. So by adding that p-value, it just shifts it side to side. So when p is greater than 0, when it's some positive number, then that causes the graph, the parabola, to shift to the right. And when p is less than 0, it shifts to the left. Now just before we move on, I want to really stress here that the basic, when we talk about that p, whatever that constant is, we always talk about it in terms of x minus p squared. And that's that negative sign. So if we subtract a positive number, that shifts it to the right. And if we subtract a negative number, that shifts it to the left. And so the example we had there of shifting to the right, remember, was y equal to x minus 2 squared. So by subtracting a positive, it shifts right. And the example we had of shifting left was y equal to x plus 1 squared, or minus negative 1, which shifts it to the left. Okay, so there's a whole bunch of examples here, and you want to be able to draw these without a calculator, and you should be able to do it without even sketching a table of values. So the goal is to be able to kind of do all of these just by following those basic patterns. We've got symmetry. We'll find our vertex. We know there's a symmetry on the left and the right. We'll decide whether it opens upwards or downwards. We'll decide whether it's going to be skinnier than normal or wider than normal, and whether it's shifted left, right, shifted up and down. So let's look at this first one. The first one, I'll do this one in blue. So f of x equal to x squared minus 2. Well, I know that it's going to look like a regular parabola in terms of how wide or narrow it is, but it's been shifted negative 2. And remember that value out here, that's the q value, that's going to shift it down 2. So my vertex is just going to happen down 2 spaces. But then I can follow the regular pattern I go through, which is over 1, up 1, over 2, up 4, over 1, up 1, over 2, up 4. And from there, I can fill in the rest of my curve. So it's going to look something like this. So there's my number 1. Let's take a look at number 2. Number 2 is y equal to 3x squared. 3x squared. It hasn't been shifted. There's no p-value, no q-value. So my vertex is going to happen right here at 0, 0. But that 3 in front is going to make it 3 times more narrow than usual, which means instead of going over 1, up 1, I'm going to go over 1, but I'm going to go up 3. And I'm going to go over 2 and then up 12. So 3, 4, 5, 6, 7, 8, 9, 10, 11, and I left myself 1 box short again. And it's going to be symmetrical. So over 1, up 3, over 2, up 12. And then I'm going to fill it in. Okay. We'll do a couple more here. So let's look at this one. Y equals x squared minus 4. Well, that minus 4, again, is just going to shift things downwards. I'm not changing my steepness at all. So my vertex is just down 1, 2, 3, 4 spaces. And I'm going over 1, up 1, over 2, up 4, over 1, up 1, over 2, up 4, and then I fill it in. And I should have more of a rounded vertex point there, but it's kind of hard to do. All right, let's try this one. Number 4. Oh, I should number all of these. This is number 2. This is number 3. And now we're doing number 4. Okay, so f of x equals negative x squared plus 3. So first let's find our vertex. That plus 3 means I'm going to go up 3 spaces. So 1, 2, 3. There's my vertex. I don't shift left or right at all. But that negative sign means I need to do the whole thing inverted. I'm going to follow the same pattern, but I need to face downwards. So I'm going to go over 1 and down 1. I'm going to go over 2 and down 4. Over 1, down 1. Over 2, down 4. And fill in my curve. So there's number 4. All right, we get 2 more. I'm going to have to double up my colors. Here's number 5. I've got x minus 2 squared. So I can see here, no a value, or the a value is 1, so I'm not going to be steeper or wider than normal, but I am going to shift over, and which way? I've got minus 2, I'm subtracting a positive number, so I'm going to shift it to the right. So that's 1, 2, my vertex is here. I go over 1, up 1, over 2, up 1, 2, 3, 4. And it's getting pretty busy in here. Over 1, up 1, over 2, up 4, but hopefully you can kind of make it out. I'm just going to do this one in a dashed format so you can tell the difference. It would be a solid line, but I want to make sure you can see the difference there. And this is number 5. And then last but not least, I've got negative x plus 1 squared. So first thing, find your vertex. Your vertex is going to be shifted one space over to the left because we're subtracting a negative. So my vertex is one space over to the left. It's right there. There's a negative sign out front, so that means it's just going to be inverted, not steeper or not more or less narrow. So I'm going to go over 1 and down 1, over 2 and down 1, 2, 3, 4, over 1, down 1, over 2, down 4, and then again I'll just do some dotted lines here. It's not pretty, it's getting busy over here, but that's okay. We should be able to figure it out. Oops, number 6. Okay, so that's it for Intro to Parabolas.